Here we prove a theorem. If two tangents are drawn to a circle from an external point, then they subtend equal angles at the center and they are equally inclined to the segment joining the center of that point. Okay, so this is a theorem. We are going to prove these two angles are equal. So it's a theorem. So first you will have to write the statement of the theorem. So statement. So this is what I just read it for you. If two tangents are drawn to a circle from an external point, then they subtend equal angles at the center and they are equally inclined to the segment joining the center of that point. Okay, let's draw the circle first. This is a point outside the circle, so it's an external point. From here, we draw a tangent to the circle. So let's draw a tangent. This is a tangent. This is a point of contact. Let us name it as P. From here, again, we draw one more tangent this side. Let this be named as Q. Okay, and this is the center of the circle. This much is clear. So what is given here? We are given a circle COR, means circle with center O and radius R. This is the meaning of this. And a point A outside the circle such that AP and AQ are tangents drawn to the circle from point A. So this is given. Okay, this is a circle with center O and radius R. It is there is a point A outside the circle and AP and AQ are drawn from this point A. Okay. Now let us join. To prove this theorem, we need to do a little bit of construction. So let us join OA, then join OP, then join OQ. Okay. So that is a construction. So what you have to prove here? You have to prove that angle AOP, AOP, that is this angle and this angle, both are equal, and that also prove this angle and this angle are also equal. That is OAP and OAQ. These two angles are also equal. So the construction part was this, what we did. I just told you, join OP, OQ and OA. Okay. Now proof. Now we know that the radius is perpendicular to the tangent through the point of contact. This is the radius and this is the point of contact, P. P is the point of contact. So radius is always perpendicular to the tangent through the point of contact. So this angle is 90 here. Similarly, this is a radius and this is a tangent here, AQ. So it is touching at the point of contact. Therefore, this angle is also 90. So you can conclude that angle OPA, OPA, OPA and OQA both are 90 degrees. Now we take these two triangles. Triangle OPA, this upper triangle and this lower triangle. So in these two triangles, we have AP is equal to AQ. These two are equal. Why are they equal? Tangent length from an external point are equal. Next, OP is equal to OQ. OP and OQ both are equal. Why they are equal? They are the radius of the same circle. And OA is equal to OA. It is a common side. Therefore, these two triangles are congruent. By which rule? Because this is side, this is side, this is side. So by SSS criteria of congruency, these two triangles are congruent. Because these two triangles are congruent, it implies that, what it implies? Angle AOP, AOP and angle AOQ both are equal. That is, these two angles are equal. And These two angles are also equal. That is, see, OAP and OAQ are also equal. See, that is, these two angles are also equal. Okay, so I think you have understood.